question number 3 is from chapter 3. Or to be specific, we focus on forces. And this is our diagram, figure 4.29. We have mass number 1 here and also mass number 2. And the question is, the figure 4.29 shows a 5 kilogram box placed on a frictionless, we have a hint here, horizontal table, and it is connected to 9 kilogram hanging box, this one, M2, by a string that passes over a pulley. So this is the pulley. Okay, so we have the information of mass here. Then frictionless, meaning that we don't have any friction. And mass number 2, okay, the second object. Then the first question is to draw the free body diagram, okay, of both boxes. So before we draw the free body diagram, we need to start from drawing or labeling the forces acted on each body. So for M1, we have weight. We label it as weight 1, W1. Normal, because it is in contact with the surface. And we don't have any friction because it is frictionless table. And we have tension. Okay, so the direction of tension is always outward from the object. And for mass number 2, we have weight W2 to be specific, and we have T. It is always outward from the object. Then for free body diagram for both boxes, okay, remember we are only allowed to draw one free body diagram for one object. Okay, so let us start with M1. So M1, we have T, we have W1, we have normal. Let us focus at these two T here, two tension. So we label it both as T. We don't label it as T1 or T2 because, okay, it is only acted on one string. Okay, so the tension is the same. Alright, so for M2, we have T upward and we have W2. Okay, that is for free body diagram for mass number 2. Then to solve B, we need to determine the acceleration of both boxes. Okay, so for acceleration of both boxes, we need to know the direction of motion. For M1, the motion is to the right, x-axis, and for M2, the motion is downward in y-axis. Okay, so as we by knowing the direction of motion, then we can have the net force. Then we can calculate the acceleration. So we start with M1. Okay, the equation is the motion of the block M1 is only in x-axis. So summation of Fx equal to Ma. Then we only have T that contribute to the motion. So it's equal to Ma. Okay, so this is equation number 1. We have T as unknown and A is also unknown. So we have two unknown parameters. So we cannot solve this question. Then we need to use the information from block number 2. So from block number 2, we deduce the equation. So we have summation of Fy is equal to Ma. So it's going to be W2 minus T is equal to Ma. So is equal to M2G minus T equal to Ma. Then we can substitute this value of T in this equation, basically. Then the equation becomes M2G minus M1A is equal to M2A. Now we can substitute the equation. Okay, we can have meaning that we can factorize the equation. Mg is equal to M1 plus M2A, and substitute A is equal to M2 is 9, G is 9.81, m1, m2, 9 plus 5. Then finally you have your A is equal to 6.3 meter per second squared. So that's for acceleration. Then to solve C, question asks us to find the tension. We just use this equation back. So it's T is equal to M1A. So we have T is equal to M1 is 5. Acceleration is 6.3. Finally, you have your tension as 31.53 Newton.